Alright, let's jump into the demo. So again, really what Lacework is doing is a couple of different things. One's going to be a host-based IDS that we deploy an agent to your Linux workloads to get visibility into how your processes are communicating. The other side is going to be AWS account security. We'll start on the workload side and then move over to the account security side. But to kind of sum things up a little bit, really what we're doing is we're collecting a lot of data, whether that's coming from network connections and tying that to processes, looking at file hashes, or from the account security side, collecting CloudTrail logs, looking at configurations. The point is, it's a lot of data. And data is great, but unless you do something with it, it doesn't have a lot of meaning. So what we're seeing here is the last 30 days, we've collected nearly 3 billion pieces of data. Now with that data, we pass it through our machine learning algorithms to build behaviors, and from those behaviors, we build baselines. Now from all of that, we're building events automatically. All these events are correlated without you taking days, weeks, months, years, trying to build out rules, correlations, give it data sets. It's all automatically done based on our ML algorithms. And then even here though, if I told you that, in the last 30 days, you've had to look at 1.1 thousand different alerts, that would still be a lot of alerts to go through and triage. But that's not really what we're doing here. Not just do we correlate these events, but we also assign a severity to them. And to that, we're also looking at the frequency that's happened, the kind of behavior. All of this goes into us building those levels of severities. So here what we're really saying is, here's 21 high and critical alerts over the past 30 days that you would have had to triage. All this other events here would help you then further do deep dives on those events that you decided, hey, these look like true indicators to me that I need to investigate, opposed to this is just benign new behavior for our environment. So again, really our product is built on going through those events. So that's where I'm going to start here, is we're going to take a look at an example of an event. Now also with our product, we're not having you come in here on a daily basis to find these. We're going to export them to whatever third-party tool you might be using in your current workflow, whether that be a Splunk, Slack, PagerDuty, ServiceNow. The idea is feed this into your current alerting mechanism, watch that, and as things pop up that pique your interest, you can then dive back into Lacework interface to do further investigations. So that's what we're seeing here. You get a new event that said new internal connection, and this is the description that you would get. So at first I get this alert and I think, okay, let's take a look here. I've got this application running on this host as this user, connecting over SSH to this host as the user root. Now for me, if I was going to triage this, I might see the user root, that's one level of concern. And then let's just say for argument's sake, I don't know what this application is. That would be enough for me to say, okay, I want to further investigate this. Now to help expedite that process, we give you what we have here, which is called the triage card. So again, obviously we have the why, that's why you came to our interface in the first place. We have the who, so this is going to be what users and also what machines were involved. We have the what, and this is where it really starts to get interesting. So we're going to give you more information about your application, how the application was running, also some really good information about the machine itself. Because if it's a case that's a pretty ephemeral environment and the machine giving it just an IP, you might not be able to track down the original source because, maybe it's spun up, spun down, it's been reassigned the IP address, whatever it might be. You have the actual AWS instance ID to look at and actually know where this event came from. Likewise, had this been a container, even Kubernetes, we would also give you the context around the container repo, container tags, Kubernetes namespace, Kubernetes pod, so you can really trace back to where this event happened. So now we got that, here's where we get some really interesting information. And that's going to be in this process section. So again, what machines were involved, process IDs, when did this happen? But then we had the exact command line argument that was ran. So I've got to be honest, this is a demo pitch, so we did some dramatic examples here. If we look, we see, okay, this was a command that launched with an argument of 10 million password list top 500. Yeah, okay, if you saw that, you'd be pretty concerned. I do know what Hydra is. It is a brute forcing app. But I think really the value here is, what if you had an app that you expected to exist in your environment, but all suddenly it's doing something new? Well, there's a lot of value to one, knowing it's doing something new, and then having this kind of data where you can see such things such as the actual command line argument, to quickly ascertaining what it was that this application and why it is behaving differently, even if it's one you expect to be in your environment. Kind of to that point too, we give you the file hash. So if it's doing something new, you can take this hash and compare it to the known good version to ensure that it hasn't been replaced, modified, whatever it might be. So continue to dive deeper on what's happening here. We give you related events as well, so you can really start to deep dive on other events, maybe even going down into low to figure out what exactly happened here. But then down here at the bottom, we have what we call the polygraph. This is essentially a visualization of what we showed above. So in this case, what we're seeing is we have this indicator, which was there was 4 instances of Hydra running that made 292 connection attempts over SSH. So there's another good indicator for me that this was a brute force attack. But that's not where we stop. We trace it all the way back, in this case, to the user activity. So I can see where they logged in from as Ubuntu over SSH, and then any process within the polygraph, we associate the user to it. So that's where you see Ubuntu there. But then they escalated their privileges, and now I can see that they're running as root. The big point here is, had this actually been a malicious user, they wouldn't want to leave their tracks behind, so they'd obfuscate, they'd delete their history. But since we're operating at the process level and streaming this back to our SaaS platform, once it's gone, there's not a whole lot they can do about it. So in that event, we talked a lot about identifying unknowns with our anomaly detection, but that's not to say that indicators aren't important as well as, threat feeds. And that's what we're seeing here. What we had done in this example is we deployed a Redis server directly exposed to the internet. Not a great idea. By default, it is pretty vulnerable, and it did in fact get compromised. And this is the alert that we saw. So this is what we looked at when we first got this to figure out what happened. So here we can see that it was a bad external IP, and essentially what they did was they connected to this host and they dropped this file. So we went in and we wanted to do the investigation. I can see the Redis user was involved. That was a little bit odd to us because we know Redis user is a no login. It shouldn't be launching applications or creating new files. Then we jumped into this what, and there's a couple of interesting things here as well, such as this. We saw that file then executed out of temp. It's pretty suspicious to see an application executing out of temp. But then coming in here, we got another indicator that this machine is running at 98% CPU usage. That's pretty high. But then I come down to the actual process that's running, and I can see this single crypto process is running at 97% CPU utilization. So that's another good indicator for me that something's really wrong here. If we come down here, we can see those related events. I'm seeing things like curl and wget to ngrok. That's not a great sign to me either. But then coming down to the polygraph, and instead of using user behavior this time, we're actually looking at how processes communicated. So here we have those bad connections into that crypto application I was talking about. And then what did that crypto application do? Well, it communicated out to nanopool.org, which is a Bitcoin mining domain. So really pretty quickly, we were able to go from saying that, hey, we believe the Redis server was compromised, to saying that when it was compromised, most likely they set up a Bitcoin mining application on that server. Now, this isn't the only set of alerts we would have received for this particular event, because we also do file integrity monitoring. Now for that, what we do is we will track the hashes of the files as they change. We will record new file hashes, but then we also do reverse lookup on all the hashes. So in this case, there's that crypto file I was talking about owned by Redis. And I can go ahead and click into here, and what that will do is launch a new dossier. You probably noticed some blue links throughout our product, and every time you see a blue link, that can send you to a new dossier that allows you to see everything that we know about it. So in this case, I can see that this hash exists on a single machine. So this gives me an idea that this was most likely an isolated incident and not something that's spreading throughout my entire environment. Again, along the ideas of helping you quickly triage and understand what's going on as few button clicks as possible, I can then click into here, which will launch me into VirusTotal, which will give me some investigation on what the possible impact here was. Again, as I said, I already suspected it was Bitcoin mining, but here's further confirmation that I was correct. Okay, what I'm going to talk about now is the actual view of our polygraph, but not from an event context, but actually from just a global of what's happening in your environment. So what I'm seeing here is actually a data flow graph, and it's not from a network standpoint, and it's not even from a host-to-host standpoint, but this is actually process-to-process level communication. Now I'm going to just do a freeform search here to kind of pare it down so we can talk about what's happening. Now what I see here is an external IP connecting to a destination IP and a port. If you know your environment pretty well, you can make the assumption that that's probably Nginx, but without actually logging into the system itself, you can't say for sure that it was because you didn't see that connection happen. But since we are an agent deployed to the actual host, I can tell you with authority that the connections that came into Nginx are in fact communicating with Nginx. But further to that point, what happens when Nginx receives a connection is it actually spawns a child process. But since we understand the relationship between those two processes, we actually went ahead and just stitched them together. So now I can go way beyond something like a VPC flow log and say connection into Nginx. Nginx then connects to HA proxy. HA proxy connects to these containers, and then here's the resources that that container phones out to. Now another important thing here is whether these were run on a VM or run inside a container doesn't really matter. Because we're at the process and network level ourselves and stitching it all together, I'm going to give you the same level of visualization regardless how it's being run. Additionally, we're really tuned for those scaling environments, so whether it's one instance of HA proxy or it scales up to 50 instances, I'm not going to show you 50 representations of that because that's not really useful. I'm just going to combine all the like behavior and give you the same visualization of that. Because really, if it's doing the same thing, do I need to see it 50 times? No, but when something new happens, something different, we'll alert you and visualize that for you. On this too, even this can get very large, even with our clustering behind it. So we do give you the ability to filter, whether that's by things like containers, application names, or we do understand the Kubernetes constructs as well. So I could show you by a virtual segmentation of a namespace, or even a pod that you have your application deployed into. Further to that point, we do have native integrations into Kubernetes and native visualizations for the structure itself. So here what you're seeing is another polygraph, but in this case we're showing you what clusters you have, what's communicating with those clusters and what are those clusters communicating with, taking it down to the namespace level. So here I can show you what namespaces you have, what's communicating with them and what are they communicating with, and then taking that all the way down to the application level, so looking at the pods. And one example that I like to show here, which kind of also fits along well with the idea of the anomaly detection, is let's take a look. Let me just find my Kube API server. So there it is. Just going to pull this out so you can see it better. And just looking at this graph, I can see, okay, normally we get internal IPs and we get connections from other Kubernetes processes. So that's fine. But pretty recently, there was a CVE posted for Kubernetes API server. Again, it's typically not a great idea to expose it to the internet anyways, because that is essentially controlling your infrastructure. But we probably all know what happens when a CVE is posted. Well, the nice people out on the internet, they decide I'm going to go scan the internet and see if anyone has it open, just to let them know maybe. Well, even if you didn't know that you had exposure or that you knew this was a problem or not, the moment that those external connections make their way directly to the API server, you would be alerted on that. You would then know that this is potentially an issue that you would then be able to go investigate and then take whatever remediation steps you need to prevent that from happening again, and hopefully prior to, actually getting exploited. As we come down here further, this acts as another great repository for, all the clusters you have deployed, the list of all the namespaces, the pods, how the communication looks between those, coming down into the nodes themselves, and then even the list of all the containers that you have deployed. So everything that we've talked about so far has been on that agent side. What I'm going to transition to now is taking a look at the account security side. And what we're going to start with is the CloudTrail anomaly detection. This is really a pretty similar conversation to the one we were just having with that polygraph, but except now, instead of looking at processes, what we're looking at is how are users behaving within that AWS environment. So here what we see is what accounts are logging in, where they're logging in from, are they using API, or if it was console, that'd be shown here, what are the principals, so all the users and roles, what regions are they accessing, what service within AWS, what's the API call, and then result of that API call. And what we're doing is we're looking for anomalies across basically all these different vectors. So whether it's a user logging in from a new location, accessing a new region, accessing a new service in that region, or even accessing or using a new API call or the result of that API call, are all different vectors that we use to help discover anomalies. So I'm going to give you a couple examples again. So this very first one, what we're seeing here is we got an alert actually because of a failed API error. Now in this case, I take a look at this and I see the why, and this is actually enough for me to understand what was going on potentially. I see a Westbecker. Now I know who that is. That's the VP of sales here. And I could see maybe he has an account to our AWS infrastructure. But what I wouldn't expect is, why is he trying to do a create stack using CloudFormation within AP Northeast? That is extremely bizarre to us. So what my immediate thought here would be, well, this is most likely, he probably wasn't too careful with his credentials and maybe somebody got a hold of them And what they're trying to do now is, poke around, figure out what access they have, and try to deploy additional infrastructure within our environment. Another example I have here is I got a high alert for a new AWS user created. Now, something important to note with our product is we do not send high alerts every time a new user is created. But in this case, it is abnormal for this user to create other new users. So that's why we sent you a high alert. I could come down here now and I can see, okay, this is the user they created, Jay Smith. I can see when this happened. It happened April 5th between 1 and 2 p.m. And I could go into these related events to really kind of deep dive and understand what happened. But to kind of illustrate the power of the polygraph, I'm going to jump back there and I'm just going to adjust my time frame. So here's April 5th and I'm going to switch this to 1 p.m. Using that new username, search for Jay Smith. And the first thing I want to do is understand exactly what was it that demo dev Dave did. So first thing I see here is, okay, they logged in through Tokyo. That was abnormal. That got flagged. They accessed IAM, and what did they do with an IAM? Well, they created that Jay Smith user. They put an S3 read policy on him. But then something else I'm noticing that's odd is it looks like they deleted it all within the same hour. So what is it that the new user actually did? Well, I can see they came in, they accessed S3, they did some read access of get objects, list buckets, and list objects. So essentially what we're trying to show here is what would happen if somebody got access to demo Dave's credentials? Well, they'd be able to do whatever he can do. In this case, it was create that new user, give them S3 access. And then what did that new user do? Well, they came in, they accessed S3, they listed all your private buckets, they listed all of your objects, and then they were actually able to copy data out of that. And then to erase their tracks, all they did was remove that user from IAM. Because if that user's no longer in there, how do you, one, know to look for this? And then even if you knew to look for it, you'd be stuck searching your CloudTrail logs to figure out what it is that happened. Where with us, we detected this purely because of these multiple different anomalous behaviors within your account. And then we give you a very quick and easy way to understand what happened and understand the potential impact of this. Now, the final section that I'm going to transition to here is on the compliance side. We can give you a global view so you can get a hierarchy view of, all the accounts that you have onboarded and, what kind of violations are they falling under. But what I'm going to do is I'm going to just dive directly into one of these reports so we can talk about the workflow and the kind of things that we're checking for. So our checks are based off of a couple things. One is going to be CIS benchmark, and the other is just going to be checks that we created based on our industry experience and customer feedback. And that's what you can see coming down here. So here you see LW, that means that was written by us. If I go a little lower, you'll see CIS, that was written by CIS. Interesting you'll notice is there was not a good set of CIS checks for S3, and that is a real way that people are having data exfiltrated today. So we stepped in and we went beyond what CIS is doing. Now, an idea of how we use this is I can come in here and we can see that I have 4 critical alerts. Now, if I read the recommendation, I look at it and think, okay, ensure the bucket ACL does not grant AWS users read permission. Now, at face value, I might think, well, of course I want my AWS users to have read permission. That's how they get access to their data. So what we do is we make it pretty easy to come in here. I can click additional info, and that'll launch me into the documentation that tells me the description of what it is, rationale behind this check, and then the remediation steps. So when AWS says AWS users, that is really what they mean. So anybody in the world with an AWS account can authenticate to their own account, and then they'd be able to read data out of these buckets. So essentially, when we have these kind of permissions set, what we're really saying is these are publicly readable. The idea here is give this to anyone in your company that might have responsibilities around deploying storage with S3, spinning up compute instances in EC2. Help them enable themselves to be part of this security ecosystem. And then when they understand why this is a problem, you can click in here. This will automatically launch you back to the AWS interface where you can then take your remediation steps. So again, that's just a general flow here. If you're interested in the kind of checks you're doing, we're happy to send you these reports. But the idea here is, again, S3 checks across IAM where you see CIS has stepped in, but we've augmented those ourselves as well where they didn't go quite far enough. Checks for logging, monitoring, networking, a general category, and then Elasticsearch as well. These are the major functions of the product. There's definitely a lot more that can be deep dove into. I'm happy to answer any questions if you have them.